Alright, hi guys. So you're on notes number 2, and the learning targets are, learning target 3.1 is still, it's about rate of change in interpreting linear functions. And the part you're going to do on this for today, because I'm going to break these notes into 2 parts, is can you find the y-intercept from an equation? And then learning target 3.2, I can graph linear equations. You guys are going to do the part where it says I can graph slope-intercept form equations. So, alright, the first part is to define what a y-intercept is. So, a y-intercept is the y-coordinate of a point where the graph intersects the y-axis. Alright, so probably one of the most important things about the y-intercept, and the reason why I'm taking the time to go over this, because you guys should already know where the y-intercept is on a graph, but really remembering that the point occurs when x is 0 and you will have some y value. So it's really important to remember that the y-intercept occurs when x is 0. Alright, the next thing to define, or just to review, is slope-intercept form. And it is a type of equation that you guys are very familiar with, but I just want to remind you what the name is, and that is the y equals mx plus b. And this is where m is the slope, b represents your y-intercept, and x and y have an infinite amount of possibilities because they represent all the different coordinates that can be on that line. Alright, so I know you guys, or at least most of you, should know how to graph a slope-intercept form equation, where you find the y-intercept, you draw it, and then you graph using the slope. But I'm going to add another step in there. So I'm going to put a star by this, that step 1 in this really should always be, especially if I ask you to do it, write the equation. Oops, sorry. Write the equation in slope-intercept form. So there will be times that I give you an equation where it's not solved for y, and so you have to do that basically. So let's put in parentheses here. This means you need to solve for y. There will be times where I specifically leave it in what's called standard form, and I will later make a distinction between those two, but for right now, if it's not solved for y, you need to do that then before you start to graph it. Alright, so we're going to do the first example, and I have fancy graph paper, and sorry, you guys just have normal graph paper, but so for example A, I want you to graph y equals -3 over 2x plus 1. So we need to first check to see if it's solved for y, and yes, it is. I made the first one easy, so it's already solved for y, so that's taken care of. So then the next step is that I identify what my y-intercept is. And so the y-intercept is always the one not next to the variable. So 1 is my y-intercept. Oh, that looks bad. Alright, so 1's the y-intercept. So that means on the y-axis, which is the vertical one, I'm going to go up 1, and I'm going to draw a dot. So then from that 1, that dot I just made, I then use my slope, and it's -3/2. And from the past and from last time, you guys should remember that it's rise over run. So that means if it is negative, I would usually, 9 times out of 10, it's just the easiest way to do it. I'm going to go down 3, and then I'm going to go to the right 2. So from my first point, I'm going to count 1, 2, 3 down. So here, 1, 2, 3, I'm making little marks. And I'm going to go 2 to the right because that's a positive 2. And so then I have a, oops, why is it doing that? I have a dot right there. And so I know it's going to go that negative direction, so I know I've gone the right way. It's going to go down from left to right. It's going to fall. I can also go technically up 3 from my original. I can go up 1, 2, 3, and over 1, 2, and I can make a dot there. And I can then connect my dots and put my lovely little arrows. And there's my graph. Alright, next example. So example B. Whoa, sorry. Example B. We're going to graph 2y minus 4 equals, 4x equals -6. So right off the bat, you should notice that it's not solved for y, right? So I do want you to solve for y in this case. So this is pulling back that stuff from the test that you just did where I asked you to solve for a variable. I don't do that just to torture you. It's because it's setting you up for this stuff. So we need to solve for y. So what do I move first? Hopefully somebody said you would move the 4x, and you would do that through addition. So you're going to add 4x to each side. That one goes away, and that goes up there. So I get 2y equals -6 plus 4x. But y is still not by itself. I have that 2 there. So I need to get rid of the 2 by dividing. And everything gets divided by 2 on that other side of the equation. And so, last test I gave you guys, I let you leave it like that. And I'm going to say, now you need to actually do some simplifying and use the fact that we know that I can do -6 divided by 2. So I'm going to do that. -6 divided by 2 is -3. And then I can do the 4x divided by 2. And that is going to give me 2x, because 4 divided by 2 is 2. So now it is solved for y, so I can graph it. So what is the y-intercept in that equation? Hopefully somebody said -3. So I'm going to go down 3, and I'm going to draw a dot. Oh, I don't like this program sometimes. Alright, so I've got my dot there, -3. And then what is my slope? It's 2, right? But 2 can still be written as a fraction, because remember, we always need rise over run. So it is 2 over 1. So that means I'm going to go up 2, 1, 2, and over 1. And that's a weird looking point. Okay. And I could keep that pattern going. I could go from that new point, I go 1, 2, and over 1. And I can go for a while if I want to. And I can also go the other direction, because technically going a -2 and a -1, a negative over a negative is a positive, so it still gives me a positive slope. So then I connect my dots, and there is my graph. Okay, so I would say that's kind of baby solving for y. that I would say that, well, okay, not maybe baby. It's probably a medium solving for y problem. Some may be a little bit more complicated than that, but not too much harder. And that is actually going to be it for notes today. And we'll finish the rest on Friday. So Eric has your assignment. Good luck and be nice to him. And please do your work. Oh, please do your work. I don't want to have to go over this again tomorrow. Thank you. Bye.